Alright folks, hello and welcome to this video lesson on slope, section 2.2. Just a quick reminder, this is a YouTube video, so you can change the speed up to 1.5 or 2.0 speed if you find this is too easy for you, and you can also slow it down if you find it's going too quickly. This will be a shorter video. We're just going to look at the concept of slope, which you learned in Algebra 1. Defining it, we define it as the slope of a line is the ratio of the vertical change to the horizontal change. Or you might have learned in Algebra 1, slope is equal to rise over run. That's usually the quick way of remembering it, where rise is the vertical change, sometimes denoted the change in y, with that fancy symbol, delta y, over change in x. However, there's also one more important formula to denote the change in y when you have two y coordinates and you want to find the difference between them, or how much one has changed. We write that as y sub 2 minus y sub 1 over, and then the change in x, how much has x changed, is noted as x sub 2 minus x sub 1. And so if you're ever given 2 points, let's just say 2, 3 and 5, 7, you can find the slope by designating one of these points as your x1 and y1, the other one as your x2 and y2, and then you can substitute accordingly into the formula to calculate the slope. So y2 here is 7, y1 is 3, so we'll do 7 minus 3 over x2 is 5, minus x1, which is 2, and we find out that this line, which contains those 2 points, has a slope of 4/3, or 4/3. Now just be careful with the signs. You are subtracting in the formula, so when you have positives and negatives, you have to be extra careful to do the correct sign notation there. Also keep in mind, it doesn't matter which point you designate as your x1 and y1 and your x2 and y2, as long as you stay consistent. It will come out the same. Next we'll look at the 4 main types of slopes. Slopes can be either positive, if they're going from the bottom left to the top right, that would be a positive slope. And we also use the term increasing. The line is increasing there if it's a positive slope. And then likewise it can be negative. Let's just draw a little example. Sorry, that's the arrow on top there. And you can have a negative slope in a line that's going down as you move from left to right. This would be negative or decreasing. And then lastly, you could have a slope of 0. Now we're thinking about rise over run, and students frequently mix these up because they try to memorize a rule instead of just thinking. So when you're thinking about rise over run, when is that fraction, rise over run, going to equal 0? Well, a fraction equals 0 when the numerator is 0. Okay, if the denominator is 0, it's undefined, which we'll look at in a second. But it's going to be rise over something. Well, if it's going to be a 0 slope, we have to have 0 over something, whatever it is. And it can't be 0 because that would be undefined. So where is the rise 0? Well, you know what that looks like. When the rise of something is 0, it will look like a flat line. Okay, so a horizontal line has a 0 slope. So the slope can be 0. And this is neither increasing nor decreasing, but it is a horizontal line. And lastly, the slope could be undefined. When is a fraction undefined? Remember, just think. Don't try to memorize a rule. If you think about it, you'll always get it right. A fraction is undefined when the denominator is 0. Okay, it doesn't matter what the numerator is. But what's going to make the denominator 0 or the run 0? Well, the run is 0 when you don't move side to side, or in other words, the graph is straight up and down. It's not running. It's not moving to the left or to the right. It simply goes up and down that line, and it will have a run of 0. Those are the 4 types of slopes. Make sure you can identify whether a slope is positive, negative, 0, or undefined. Next, we'll look at the slopes of parallel and perpendicular lines. There are 2 very important facts here. One is that the slope of parallel line, or the slopes of parallel lines, are equal. And this should intuitively make sense to you, because if you remember from geometry, parallel lines are lines that never intersect. So if I have the xy plane here and I draw 2 lines that don't intersect, there's one, there's another. Well, in order for them never to touch, because remember, lines are infinite and extend without end. If they are to never to touch, even somewhere as you go way up into the first quadrant, way down into the left quadrant, they have to be increasing at the same rate. So they stay the same distance apart at every point. And also, they have to be the same steepness, because if one's steeper than another, then eventually they're going to cross. And slope is another word for steepness. So the slopes of parallel lines have to be the same, because the steepness has to be the same, or the angle has to be the same in order for them not to intersect. So that's kind of an explanation of that fact in an informal argument. But what about perpendicular lines? Those slopes are opposite reciprocals. A curious fact, remember the opposite reciprocal means that if you have a number x, well, its opposite reciprocal would be negative, or the opposite sign, 1 over x. Okay, and notice when you multiply these two things, you get negative 1. So sometimes this fact is recalled as saying opposite reciprocals are two numbers that multiply to negative 1. So if you have a slope of 3 on one line, then you know taking the slope of a perpendicular line, it will be negative 1/3. Okay, you flip the number, the rational number, and take the opposite sign. But why is this so? And how do we know that this is true? Well, that's a trickier question. Let's look at a bit of a proof for this, or an argument, a logical argument that leads to the conclusion that the slopes are opposite reciprocals. As you get more sophisticated in Algebra 2 and beyond, you should be asking that question yourself. Don't wait for me to ask it. Ask yourself, how do we know something is true? And what previous facts allow us to declare that it is true? We're not going to be doing a lot of things that just come out of nowhere, and I just tell you, oh yeah, this is the formula because I told you so. All right, that's not what we're encouraging in high school mathematics. We want you to be able to think through an argument for the formula or a proof of the formula. So where does this come from? Well, let's draw a right triangle here. Think back to your geometry days. Let's say this line is the line we're looking at, and notice you could draw it any way you'd like. It could be steeper, it could be less steep. So this is just some general line, L1. And let's label this right triangle A for the short leg, B for the longer leg, and then C for the hypotenuse. You might be thinking Pythagorean theorem. That would be right. You could use that to find the length of the hypotenuse and some other things. So there's L1. Now I want to draw L2, and I want to make it so that it is perpendicular to L1. L2 is perpendicular to L1. There's L2. Now notice, when I draw that, it's the same as if I were to rotate this triangle 90 degrees counterclockwise, or 90 degrees in the positive direction. And when you do that, you'll get a second triangle up here that looks like that. Now labeling this triangle, notice here is B, that length, and now it becomes up here B with a longer leg of the triangle, so there I'll put a B, and then here's A in its length, so this will also be A in its length. However, now we're going in the left direction, so horizontally this will become the opposite of A as you look at the coordinates, and then this you could label C if you want to label the distance, but I'm not as concerned with that because A and B are going to give us the slope. So what is the slope of L1? Slope of L1 is the rise over run. Looking at L1, the rise here would be A, and the run would be B, or simply the ratio of A divided by B. What's the slope of L2? Looking at the rise over run now, well here our rise, or actually technically it's a fall, is B, as our run is the opposite of A in length. So if we were to write that fraction, it would be the B over the opposite of A, which could be written as the opposite of B over A. Or in other words, the opposite reciprocal. Since A over B times opposite of B over A equals to -1, we know that these two fractions are opposite reciprocals, and we have just proven the general rule for perpendicular lines. The reason this counts as a general proof is because I didn't pick numbers for A and B. I particularly chose to use variables because they can stand for any real number on this coordinate plane, and we can use the same argument. Okay, if you need to replay that back to follow the steps of that argument, please do so, and ask me a question in class if there's something you didn't understand. So let's recap what we did in section 2.2. First, we examined slope as the concept of rise over run, vertical change to horizontal change, the ratio. Then we looked at two different kinds of slopes. Secondly, we looked at four different kinds of slopes. You can have a positive or negative slope. You can also have a slope that is undefined or zero. And don't try to memorize a rule. Just think, when is the rise 0? When is the run 0? What does that look like? And then lastly, we had some parallel and perpendicular facts. You have to know that the slopes of parallel lines are equal, and the slopes of perpendicular lines are opposite reciprocals. And finally, we looked at a proof for how we know this to be the case, that the slopes of perpendicular lines are opposite reciprocals. And you may have found that a little bit challenging because it draws on geometry knowledge, but it's a good practice for your first proof in this class. Thank you for watching this video lesson on section 2.2.